On the turf side, we want aesthetics, durability. We want to keep the playing quality up to include stimp speeds or faster ball speeds and consistent putting surfaces. So that's with our goal at the end in mind and what we're shooting for. When we look at what's tied up in your soil or what you need to put into the plant, we have to have it in two parts. The first parts are what issues could be causing it to be tied up. It could be a pH issue. It could be a plus minus issue, like for calcium is a double plus, so it may grab a negative soil colloid in a heartbeat, as well as weight and balance issue. You know, when I call weight and balance, I'm referring to too much of one versus not enough in the other. The most common ones with that is your sodium. Let's look at, well, the sodium is most common. This is what we call the wheel of death or our binding wheel. Potassium is the most common because in all of your leaf tissue tests or soil samples, the plant will take up the sodium before potassium if there's too much. So that's the most common one everyone looks at. However, the one that's the most abundant in the soil and has a tendency to be tied up most is phosphorus. If you look at the bottom center of this wheel, phosphorus is here. And the way you read this is magnesium can tie it up. It only takes a little bit of phosphorus to tie up magnesium, and magnesium takes a lot of magnesium to tie up phosphorus. There's no one-way tie-up. Look at it as if I grab your hair, I'm tied up with your hair. Just because I loosen, I have to let go of your hair before your hair is available to you. So that's how we look at it. So there's no one-way tie-up. It's going to tie up both of them. So under phosphorus, it can be tied up by manganese, magnesium, and we come around the wheel, copper, calcium, iron, and zinc. So there's an abundance of things that could do it. Now, once we look at this tie-up, too much is just as bad as not enough because of how it's brought into the plant. So the next chart I'm going to show you looks at the pH levels where phosphorus may interact with excessive calcium, iron, and aluminum. Now, in that far left column, I'm just looking at the three because those three have a different range in the pH scale, but yet anything in this scale could affect it. So now this is the one that everyone's very commonly seen out there. If you look at the first circle here on the left, iron is available at low pHs. So that means it's going to stay in solution. It's not going to fall out. It's more accessible by just being dissolved in water. And then as the pH rises, aluminum will kick in and tie up phosphorus. And then at the end on our list, the calcium is at the other side. So we're looking at this gap right in here is where we want to be. So we want to be less than 7. Well, here, let me show you on this chart. If I do a pH level, this first lowest level is going to be fixated by iron. And then as you move the pH over, aluminum kicks in and calcium. So now I'm looking at this pH right in here, which is my lowest availability. I mean, I should say my highest availability and least amount of tie-up. That doesn't mean it's not tied up because you still have it tied up here. It's just easier for the plant or the most accessible to the plant at these lower or this pH range in between here and here. All right, now we've determined where it's at or what might be tied up in the soil. The next thing we want to look at is what's in the plant. So if we know where we are, we want to know where we're going next. The things that we're looking at in this top left-hand corner, we're looking at the chlorophyll process. So you're looking at your Mg and nitrogen and your energy coming from your iron electron. So this is what a lot of people will concentrate on initially. 1 molecule of Mg, 4 molecules of nitrogen, and then they break down this electron for the energy. This is done here with the sun. As it's shifted through this process, the amino acids take place on the other side of the sun, or the dark side of the plant is what I refer to it as, not necessarily at night, but in the part of the plant that doesn't need sunlight to operate. We're looking at the Krebs cycle as well as the Calvin cycle. People concentrate on the Krebs cycle, but yet the Calvin cycle is the tipping point in the Krebs cycle to make your plant more efficient and productive in that. So as we're looking at this whole formula, we then break down just that upper part. If I look at this nitrogen electron, how do I get this here to be more efficient? This graph here tells me how to be more efficient in the chlorophyll process. My 4 nitrogen I must have a ratio of 1 to 10 on sulfur to make this nitrogen easily bindable. But then I look at this side, my magnesium in the center requires calcium to connect it. They have to be connected by something, and it's with the calcium. Now, once I do that, I have to have the energy to form that connection. That's here with your iron. Things that affect your iron availability or nitrogen, the energy levels in that iron could be Mn, Zn, or copper. Now, if you're noticing these things, as it pertains to the plant, copper helps fight pathogens. Zinc helps regulate the temperature of the plant. And Mn also helps fight pathogens or makes an environment not indicative for the pathogens to proliferate. So as the iron is breaking down to get the energy, the plant uses these byproducts from these micronutrients to stay healthy. Now, on the other side of it, things that may affect the iron availability, high phosphates, organic matter, and high sand. So if we balance this or keep all these things in mind in the chlorophyll process, it will help us get to the next level for how to get to the phosphorus in it. Okay, where we're going is done and how we get there. So right now, if you have stuff being bound up in the soil, the roots are not always necessarily the easiest way to get it into the plant. How can we bypass the roots to get the nutrients in a balance? What we look at for that, and we take this as from your marketplace. If you go to the supermarket, they spray water on there to keep the vegetables fresher longer. There are no roots, well, with the exception of carrots or radishes, there are no roots absorbing water at the supermarket. It's getting into the plant and keeping it fresh somehow. It's not just the cold. So as we're getting there, it's getting into the plant through the stoma. Now the stoma here in the top right-hand corner, if you'll look at it, has these, doors that open and close. These levers will open and close and let oxygen out, it lets water out, and it lets CO2 in. And this is where the plant is passing it back and forth through the atmosphere. Now, the key is, do we have the technology to get these doors to open so that we can get it into the plant? And can we get them to go into more efficiently to the right spots of the plant? Now, to do that on the glucose side of the house, that's what we're looking at. We want to get into the glycosylates and the glucose side of the house. So depending upon the plant type will depend on how and where more efficient it is. Most of you guys in Canada, well, I don't know anyone that's not C3, because C3 is your cool weather turf. C4 would be your Bermudas and that type turf, and you guys don't really see that up there. But anyway, here is the entry point in which we get it in where the oxygen water is coming out. Now on your C4s, there's extra pieces in here for the mesocell that we have to bypass around. Now, this is a two-dimensional look, but I actually need to see it three-dimensionally to figure out how to get it into the plant and where it's running from. And with that, I'm looking at the sheath bundle cells on how it gets to this end of the plant from that end of the plant. Now on your C3, you're missing that on the sheath bundle cells, and that's going to be in this area here. So we have to figure out how to best efficiently get it in there without the plant having to work extra. Let's go to the next one here. Okay, so now we've looked at the structure of the plant. We're going to have to determine the mode and how else are we going to get there. Working smarter and not harder of the plant. So all right, let's go. There we go. For us, what we do to do that, we use biostimulants. We get one plant that's already done the work to feed or utilize into the other plant and get it to have to do less work because the work's already done by another plant. So the three biggest things that we use are auxins, cytokines, and gibberellins. And you can't just say, I have a gibberellin. There are over 156 to 158 gibberellins out there. Those of you use it, you try to keep your grass from growing or elongating. You have modify the GMOs in the plant, which the GA1, that's a gibberellin. It's inhibiting the plant growth under GA1. So for our products to keep it compatible with your growth inhibitors, we want to make sure we don't use GA1 and counter that. So on a Jabrilians on our side of the house, we use 6 primarily. The most common you'll hear is GA6 and GA3, but that's what we're using to make sure that we're not inhibiting your growth inhibitors. And then also cytokines and auxins, we have to balance them out. Most people won't touch auxins, but they all work in concert and they all have to be balanced out. So you need to look at all of them. And if you don't know where it's coming from in the plant, your Jabrilians are produced in the leafy portions of the plant. Your auxins are produced in the stem portions. Cytokines are produced in the roots. Cytokines travel up, auxins go up and down, Jabrilians come down. And that's what we look at to figure out what the balance needs to be and how much is being produced by your crop or your plant. Okay, do we just make this stuff up and guess what it is? No, there's references. If you'll notice, bluegrass, orchard grass, and oats, those are all C3s here. Then C4s are not listed here in highlight, but they are there. You know, Napier grass, Para grass, your Bermuda grass are C4s. Now on the other side of the house, we do look at rice, wheat, corn. Rice and wheat are C3s, corn is C4s. It's the same process, but yet different amounts. Just because they're plants doesn't mean they use all the same amount of iron. They don't use all the same amounts of nitrogen. So we have to keep that plant specific to help see what's going on in the plant. Okay, so once we determine how we're going to get there, we then need to know the other half of what's physically in your plant so we know how to make up the difference. Now, most of you guys do your soil samples and you'll do a paste extract or an exchangeable sample. Under exchangeable, they're using acetic acid to do that test. While that is a base that you can use to estimate what's there, we don't prefer that because the plant has to use up extra carbohydrates to produce that acid in that test. We prefer the extractable because we want it as easy as possible in the plant. And extractable uses distilled water as your base, and that base is what's coming out on the CEC. So I know what's happening in your soil, and your CEC is derived by what's in the soil. Other tests that we can use to determine, we can use a tissue test or a Brix test, and your calcium is really obvious in your Brix test on how thick the cell walls are. Your tissue test tells us is the plant pulling up your sodium instead of your potassium. So, you know, each one does its own function. Okay, this pretty much recaps what I was just saying there, exchangeable or extractable versus tissue and Brix. Okay, other things. Now, we were concentrating on phosphorus before, so that's what I'm going to look at here real quick. Things that could affect phosphorus salinity. Anytime you see the word salinity, you know that's the water test or the paste extract. If you don't see salinity, it could be an acid test, and then you need to do more research to make sure you're comparing apples to apples at that time. But all of these factors here can affect how the phosphorus is absorbed into the plant. And if you'll notice, most of this list here, calcium, iron, magnesium, those are all included in our binding wheel. So we know that that's going to bind in the soil. Now, things that we're looking at under the paste extract, we're looking for at least 8 parts per million. If it's less than 8 parts per million, you're hurting. Your phosphorus is too low, you're not going to have any energy. Optimal for us is over 16 parts per million. Anything in the middle is when you're doing the balancing act and you're paying attention to your plant every day. So those are the ranges that we're shooting for in a extractable. Now, if it's an exchangeable one, it's done on line 3, very similar in nature, although we do know that more sodium is dissolved in water than in acid, so we can't take your sodium counts to affect your phosphorus in the same way under the exchangeable. Now on exchangeable, we're looking at different rates because it dissolves differently in acid. Less than 29 parts per million is low, and then your medium levels or optimal ranges is 30 to 40. Anything over 41 to 70, it's high, and it can be affecting other micronutrients within your soil. Here are tissue results, same issue. We look at it and we break it down what we're expecting and what we're wanting. Okay, exchangeable and extractable, you guys, most of you guys are using Harris Labs, and I say Harris Labs with a grain of salt because Harris Labs was bought out by AgSource, so they're the same company. AgSource has been recently bought out by Voss, so if you see any of these three, you're dealing with the same people, the same tests, the same way. Outside of that, you really have to start digging into your soil research to see how they're doing the tests and what they're doing. I pulled this one up just from a sample. Canmore golf course. We're looking at, here it says PO4 salinity right here. So we know at that point we're using a paste extract because it says salinity. And then these numbers, 0.93, 0.72 parts per million. These are all parts per million. So then at that point, we know from the chart before, the phosphorus is low to support plant energy. We either need to be applying it to the soil to get it in or bypassing the soil and applying it straight to the plant leaf foliarly and to help get that. Now on this one, I pulled, this one is a same type of paste extract, but this one is for a grape field, I believe. So grapes don't use phosphorus in the same amount, but it does say salinity, so I know it is a paste extract. We are looking for different, see it's higher, 2.88 and 1.34. These are considerably higher compared to the last one, but yet it has a low end of availability or a low end of adequate because their plant or the grape plant does require more phosphorus than turf to operate. Now, looking at the grape side, I'm just going to use this as an example. We can do this, or we do this, the same thing with the turf side, but I'm going to just switch the example to grapes. There are dozens of pathogens out there that could cause the plant to start to deteriorate or attack the plant. So we need to look at the vascular and foliar system of the plant, which when we did the C3, C4, it's the same thing, as well as we need to look at what's indicative to the health and or deterring that pathogen or pathogens, an environment that it's indicative for the pathogen to proliferate. And how we do that, we look at a physical aspect, a chemical aspect, and a microbial aspect of not only the plant, but we balance it with a pathogen that we don't want. So we look at trying to make the plant healthier and stronger, more vibrant. So if there's a little bit of pathogen, it doesn't affect the plant, or it can live with it, still survive. We look at different ways to chemically enact the SAR, which is the systemic acquired resistance of the plant. For us in our bodies, it's the equivalent to not being sick, but the white blood cell jumps up. We can do things to our body that cause your white blood cell count to increase. And this way, if you do get sick, it knocks it out quicker. It's the same thing in the plant. We can do the same thing. And then on the microbial side, we look at things that the plant can utilize. And so we're getting a dual utilization out of it. However, it doesn't create an environment that's indicative for pathogens to proliferate. We make it harder for the pathogens to survive, I guess is the best way to look at it. Okay, this is basically the same thing I was just recapping when I just went over the systemic acquired resistance. Sometimes you hear it called ASR. It's acquired systemic resistance, is the same thing. We're looking at trying to do this without spending extra. If you don't have to spray to kill the pathogen and your plants are healthier, it'll save you money in the long run, as well as keep your plant healthier. Your last bullet point here, the monopotassium phosphate, which we use phosphates in the second bulletin, but that's with a phosphoric acid and potassium hydroxide. Now the monophosphate, this combination is very similar to aloette. Aloette will work without aluminum, but the regulators in the US say it's not registered that way. You can't do it that way. You have to have something added. So aloette adds aluminum just so that they can get US registration. Well, we take that technology and slide it into our products so that the plant doesn't really use aluminum, so we don't put the aluminum in with it. But it still does the same exact thing, works the same way. Okay, with that, I was looking at opening up the question portion. What I just covered is literally a 3-day class that I typically give. So I covered a lot of general stuff very quickly to make sure I had room for questions.
So how do you think that our science, because there's not a whole lot of this particular science that necessarily gets explained in our line of work. So would you like to talk briefly about how our science stands out and how it came to be?
Okay. What we used to, when we were doing facial creams, we also supplied raw materials to other companies that do the same thing we do. And when we give them advisement on how to apply it. And then as the science developed, it got more expensive. And some of the other companies didn't think that it was worth putting the extra quality and the extra money into utilizing the science. So that's at the point where we said, hey, this is an extra step that we think it's worth it for the plant to go in this direction. And that's pretty much how our company got developed, or I guess expanded. We went from supplying raw materials and giving advice on how to use it to utilizing the advances in science to help make our own product is basically what we've done. We use everything from whey products, which is what we used in facial creams. We did initially start with whey products. So the cow, even though a cow is an animal, it still produces carbon and carbohydrates and long chain proteins just like the plant produces. So we have the technology to be able to extract out the long chain proteins from the cows or from animals and utilize it in the plant. And that's the difference between the N14 and the N15 nitrogen. So those type of scientific advancements is what has allowed or made our product stand out in the marketplace.
Awesome. I'd like to open it up to the floor if anybody else has any questions.
Joe, it's Pat Differ here.
Yes, sir.
From a user standpoint, I think one of the ways that I always tried to explain your product was that it goes beyond our normal training and mentality of feeding things and the soil and the tie-ups, and it helps us really be more in control of a plant's systems. And when the time comes, because it does for everybody, to deal with stress, it's really important that the raw materials that are in the jug that you're putting on the golf course have the proper ratios and control mechanisms to elicit a response out of that plant that you want it to have. And more than anything I've seen in my time in this business, your stuff does that. So you're really talking about control. And that's really what it's all about. And there's a comfort in that for most turf managers. That's all I wanted to say.
A lot of the times we don't realize some of the benefit that you're receiving or what's going on behind the screen. When you pull the screen back, you're getting longer roots, but you got the green, and that's all they care about. The turf guys, they pay greens fees, so they want the grass green. I had a guy in Florida, and he had C4. As soon as they get a frost, their warm weather grass goes to sleep. Well, he just so happened to have the mix that he added a silicone in it, and he just sprayed the day before, and it was coincidental that he sprayed, and it frosted that night. All the courses around him turned brown, and he was like, well, why did mine not turn brown? And I was like, well, what did you spray? And then he went through his tank mix, and there's a lot in the background that he wasn't seeing. The zinc was balanced with the nitrogen, which allowed the plant to regulate its temperature, but he had a tournament coming up, so he sprayed a silicone product on there to get the turf to stand up. I call it butch wax for grass because it gets it to stand up, gets it firmer, and as a cart runs over, the plant's more durable and withstands the carts. Well, he sprayed because he's expecting a lot of foot traffic. And then what he didn't realize he was getting was when the orange fields get frost, they spray water on it in hopes to get the water to freeze to protect the orange from dying from frost or getting frostbite. Well, it was the same thing with his grass. When he sprayed it, it put a light coat, a silicone on the plant. The plant had the health and long root system to where it wasn't affected, and the health of the plant was good. The zinc in there balanced the temperature of the plant to withstand that cold weather. And while his neighbors were getting, or the courses around him were starting to go dormant because of the frost, he was able to have a tournament play, and his greens looked twice as good because they literally drove by the course next to him to get to his course. And they're going, hey, we're playing on green field still, and everyone around us is dying. Well, was the product great? Well, no, the product is working properly and eliciting the right response out of the plant to get it to survive longer, because no plant commits suicide. The plant's going to want to live. So we just give it the availability to live longer, healthier, with the least amount of energy. And if they don't have to use up the carbon or all the nitrogen, the plant can do it easier and has the ability to stay green longer.
Joe, or everyone, I guess I had lots of comments, I guess, that I'd rather, let everybody else contribute where they want. But again, I've been, like maybe all of us, he's been around a long time too, I see on here. And, the benefit and the value of what Pro-T offers, again, his third and fourth generation of anything that was available years ago with respect to formulations and chemistry. And what that does to me, just to speak in old language, is it takes a couple of jugs 20 years ago to create a response, and now that can be done with one jug, and in some cases 3 different combinations of what we used to do to control the growth of a plant can now be done with the combination of the formulating in one jug. And so at the end of the day, when you sit right down and compare a kitchen sink syndrome of 6 or 8 or 12 things in a tank, as the business evolved and as foliar chemistries evolved, that sort of logic or mentality isn't even really necessary anymore to create the response that you want. Pro-T has the benefit of, to me, program-wise, really simplicity, which again equals results because of the quality of what's in the jugs and the formulations that have been prepared over time. This didn't happen overnight, but you're dealing with materials that can save a considerable amount of money when compared to other things that are out there today as well. And that's part of the goal. Number one goal is going to be plant health, but I'm sorry to jump in and be saying things. I'm making more comments than asking questions, but to me, the benefit is clear, and it's no more clear than after you spray this stuff for the first time, and then the second time, and then your plant gets conditioned. And to me, it just fits into everybody's wheelhouse and creates a real comfort zone, knowing that you have done what you need to do to make sure your grass can respond to what it's going to face. So, those are all comments based on a long time on the road and a long time in the trenches in this business, really dealing with a whole broad spectrum of different things. And there is no question to me that without all of the hoopla and advertising and firecrackers that go off when people try to tell you how good their products are, Pro-T is a stealthy, silent, comparatively speaking. You're not seeing a whole lot of fancy things, but what you will see is results. So that's another comment.
And well, I think to my own detriment, I'm not a salesperson, and that does hurt the company, because a lot of times when people say, I have this problem, I can't go, oh, you need product XYZ to fix it. I go, if you notice on the presentation I just gave, I didn't mention it. A single product name, or the only product names I mentioned, weren't even our company. That's just who does our soil samples. I look at the science, and then I say, okay, you're having this problem, you need this, this, and this. I then have to go to the toolbox and look and say, all right, which one of our products have this in it to solve that issue? And I think that is to our detriment a little, but yet that's what makes us successful, because I have nothing to do with product names. I don't do anything with money. I look at what it takes to fix a problem at the scientific level. And hence that's where our saying comes, success through science, is, all right, I need this to be a little greener. I need this to be more efficient. What do I need to do to get it there? Not what product do I need to apply for. And it does hurt you guys in the sales side of it, but yet it helps at the same side because it works when they use it, they see it, and it'll jump out at them quicker and easier. Long chain proteins versus short chain proteins, it's basically looking at the difference between N14 nitrogen and N15 nitrogen. N14 nitrogen is synthetic, typically, something like urea. It works, but yet the efficiency of it is not there. The N15 nitrogen is an organic compound that takes just a hair longer to break down. However, you get more bang for your buck. The extra long chain protein gives you the extra energy as well as length of time. It does take a little longer for the microbe to break it down and utilize it, but yet it's being utilized throughout the plant. So it kind of stretches out your green as well. Now, mostly that is helping the Calvin cycle. When the acetyl-CoA goes around, it does a loop and uses up some nitrogen, and it uses that protein off the long chain, and then it will go around again. It has to combine 6 of them together to make that molecule. And that's not having to be done as difficult on the plant as it goes or utilizes the long chain protein versus, say something's going into senescence. If your plant is going into senescence and you're giving it regular nitrogen and it's not making that, finishing that connection, it will utilize your nitrogen and keep going through nitrogen and not make, it won't attach to acetyl-CoA, and it'll go around and try it again. And it'll just use up your nitrogen, and then your plant will senesce more. And then it gives off that carbon dioxide or that senescing gas. And now the bugs are saying, hey, there's not much protein in, or there's not much sugar in there. Bugs do not have the ability to, they don't have a liver and can't process sugar. So if they're going to attack a plant, it's going to be one giving off gases from senescence because they know they can digest it better. So by keeping the plant healthier and easier to work, you have less infestation from your bugs, as well as your plant works, doesn't have to work as hard to utilize that nitrogen. And I realize that's verbal, but I have charts and stuff for class that help explain that a little bit better. And you actually visually see it going around in the cycle and how the plant utilizes it.
Joe, is there a resource for our customers that they can get more further understanding on the science behind this?
We have a couple pamphlets that talk about it, and mostly the pamphlets will show you the balance of cytokines, auxins, and gibberellins, because most people don't concentrate in those areas. But we do have some, I guess there's even an electronic one, but it's a brochure that will tell you what's each product's balance. So if you're looking for, if you personally want to go with more cytokines, you can look at which products are heavy cytokines, because there's no place on the label for cytokine. So the brochure will help you show what tank mixes work well together, and or increase your, if you want to increase auxins, you know which applications to apply. I can get it to you. I can send it to Russ, or I think Russ may even have it's a PDF. It comes in a PDF. It also comes in a hard form. If we were at like a trade show or something, we can hand him out in hard copy. Oh, well, yeah, I have access to a ton of classes, and I normally give like this. Like I was saying today, the one today was 1 hour or half hour compressed into a three-day class. But we also have, if you want me to come and do it for your staff, I can do that too. Although it's a little more difficult with COVID. I've been doing them more like Zoom like this now, but I mean, we can go either way. I can put presentations together if you guys need them. I can do it either way.
Okay, I think it's time to wrap it up, just because I don't want anyone to get cut off or anything. So I'd like to thank everyone for joining in on the meeting, and thank you, Joe, for the wonderful presentation. And if you have any questions, please feel free to email either myself or Russ or Peter or Dave or Tim. Yeah, okay. Thanks, you guys.
Thanks, guys.